Good evening, everyone. Myself Gautam Sarma. I welcome you all in a Sapience Education. So today I am going to discuss about the transformer. This is the eighth part of the alternating current. If you want to go for a further more details and a topic, so you can go ahead. You can visit our website, YouTube channel, as well as you can also see the playlist of the alternating current. So I will today discuss about the various types of transformer and what is the basic principle of the transformer. So from your figure, you can observe that this is the transformer structure of the transfer. So first of all, we need to understand the basics of the transformer. What is the basic of the transformer? So first of all, how many types of transformers are there? So let us write it. Transformer. So this is of two types. If we talk about the types of a transformer, what happens? There are two types of a transformer. That is step up, and second is step down. Step down. In this, voltage will be increased. In this type, voltage will get increased, and in this type, voltage will get decreased. Voltage will get decreased. So if whenever we want to either increase or decrease the voltage, so we will use the transformer. Now what is the basic principle of this? Principle is means basic principle. If we talk about the basic principle, it is a mutual inductance, mutual induction. Induction. Okay. So basically what happens, let us consider this is a transformer. Okay. And if you put a primary coil, if you put a primary coil like this, so this is, let us suppose this is a coil and there is another coil. So if you apply an AC source current, so what happens? We know that AC, either it is increasing or decreasing. So if current will change, so what will happen? There will be a flux which will be changed. So if flux will change, so what will happen? It will create a mm, field, magnetic field. So and there flux, and there will be change in a flux. Whenever there is a change in flux, so there will be also a change in flux in a secondary coil, right? Secondary coil. So this is the basic thing. So when this happens, then what will happen? There will be an induced EMF. Induced EMF. So how you will write it? See, basic principle is mutual inductance. We can write it when a current is passed through primary coil, primary coil, AC current, then due to variable nature of AC supply, variable nature of AC supply, there will be a there will be a change in flux, which results in induced EMF, induced EMF in secondary coil. Induced EMF in a secondary coil, which results the source output source. So basically what happens when we apply, when we supply a AC current, so what will happen? There will be a change in a flux, and when there will be a change in a flux, so there is also a change in flux in this coil, and after this there will be an induced EMF in this, and this is the known as principle of mutual inductance. Okay, so mutually there will be a interchange in the power. Now one more thing is that as per the conservation, you cannot get any power or you cannot get any energy without supply. So it means that power will remain constant. Power input is equal to power output. Power output. Whatever we are giving power, so our output power will be equal to input power, or maximum what happened, output power is less than input power or equal to. So this is the scenario. Now we know that power is equal to V into I. Now if voltage will increase, that is for step up, current will get reduced, but power will remain constant. Now it may happen if voltage decreases, so what will happen, current will increase, but product of this will remain constant because power supply will be constant. So either power input or output, both will remain same. Now from here what we can say, that if we talk about this, so power output is equal to power input. So power output is equal to V, or voltage output, by current output is equal to power input, voltage input, by power current input, right? So we can see, or we can see like this. Okay, so these are the equation we can find. Now what DC can be used as a step up. Now see, one more question is there, whether DC can be used for step up and or step down, step up or step down. The answer will be no. Why? Because no change in a flux happen. Because no change in flux happens, right? Now we will go for the derivation part. Let us consider this is a transformer. This is a transformer like this. So this is your transformer, and this is what we can say. This is in input power. It is known as primary coil, and there is another coil. It can be considered as a secondary coil. Output. So this is known as secondary coil. Secondary coil. Now when we but this see this is what we have, but actually practically when you observe, then you will find that let us consider this is a transformer. So transformer structure is such that it will have this type of creation. Okay, now in this what happens, let us consider there is an input power supply like this input. So and output coil will be winded at this at the same place, such that 100% flux will be passed through this coil. Flux will be passed through the coil, passed through the coil, through the coil, so that flux leakage will be minimized. Flux leakage can be minimized, right? So this is the practically transformer. If you observe this, so this you will get. Now you know that these are the plates. These are the so many plates. It has been made with the so many plates. Why plates? So many plates has been used. See, each and every plates are coated or are insulated. such that there may be possibility that when you pass this current, so what will happen, there will be an eddy current formation happens, eddy current formation happens, due to which what will happen, loss of power will may happens. So to avoid this several plates has been used. Okay, so basically transformer basic principle is, it is all about the mutual inductance. Okay, and how the magnetic field is being conducted. See here, magnetic field, either if this type of structure is there, so magnetic field will form like this. But when we talk about this, so see, magnetic field will be formed like this. So due to this, what will happen, 100% field will try to pass through the secondary coil. So this is primary coil and this is secondary coil. So when primary coil will create a magnetic field, so it will mostly pass through the secondary coil. So this structure is the best structure. So I hope you have understood this. Now we know that the supply input is like this. So this is a supply input. Supply input is like this. So this is positive, negative, positive, like this. Since magnetic field, you know that magnetic, due to AC current, magnetic field will be created. Magnetic field will be created. As a result, what will happen? Induced EMF is being produced in the secondary coil. Induced EMF is being produced in the secondary coil. Is being produced in secondary coil. Secondary coil. Right. Now from this, now can, if there is a no loss for no loss, no eddy current loss, no heat loss, so for ideal condition, for ideal transformer ideal transformer for ideal transformer, power input is equal to power output. We can say that power input is equal to power output, that is power in a secondary primary coil is equal to power in a secondary coil. So from here we can write that power, we know that power is equal to voltage into current. So here we can write that power in primary coil into current in primary coil is equal to power voltage in a secondary coil in current in a secondary coil. So from here we can also put here EP by ES is equal to IS by IP. Okay. So from here what we have got, E is inversely proportional to the current. If voltage will be increased, so step up, what happens? Voltage will increase. Voltage will increase. So as a result, current will get reduced. I will reduced. But when we talk about the step down transformer, voltage will decrease and I will increase. So I hope you have understood this. Got it? Now, you know that there is an induced in a EMF. So if there is an n turns in the transformer, so let us consider this is a transformer, and so there is a n number of turns like this, like this. So so what will happen? If there is n turns in the secondary coil, so can we write here that EMF produced is equal to minus n di by dt. Also, EMF produced in a primary coil can be written as NP di, current, it will be flux, change in a flux, so this will be d phi by dt, and ES can be written as NS d phi by dt. Now change in a flux will happen, rate of change of flux will be constant for both the coil, constant for both the coil. Why it is constant? See, when we are talking about constant, why it is constant for both the colors? Because see, both are coil are placed in such a way that area is constant and rate of change of flux will remain constant for both. So it means that d phi by dt will remain constant. So just equate it. So it is 1 and it is 2. So from 1 and 2 we can say that np, we can say that ep can be written as like this also. Ep 1 2, just if you divide it, ep by es, so can be written as np by ns. And ep by es can also be written as is by ip. So important, and this relation is known as transformation ratio. This relation is known as transformation ratio. Formation ratio. So this will be very much helpful for getting any type of unknown relation. So this is very important, right? Now from here what we have also observed that E is proportional to N. If you want to increase the EMF, so you have to increase the number of turn. Okay. And if you want to decrease the EMF, so you can decrease the number of turn. Decrease the number of turn. Right. So if you want to increase the EMF, so you will get increased. If you want to decrease the EMF, so you have to decrease the number of turns. So these are the things you have to understand. Right. Now if we have already understood this, right? So for let us consider step up. What happened? We want to increase the voltage, so increase the number of turn in primary coil, secondary coil, sorry, secondary coil. If it is step down, so what will happen? Increase number of turns in decrease in number of turns in secondary coil. So I hope you have understood this. Now if you want to find the efficiency of the transformer, so how you will find transformer? So this is very important. Efficiency of the transformer is equal to output power by input power into 100. Okay, so this is very important. In next video I will discuss about the energy losses in the transformer. Thank you. Hope so you have enjoyed the session. So in this next video I will come up with the very important thing, that is losses. Thank you.